Kein Zitke. Ist okay, kein Thema. Okay, I think we can start. Are there any non-native German speakers in here? Okay. So this meetup will be recorded and screencasted worldwide, and also I'll provide the link to the recording so you can then distribute it if you like, or you can go home and I send you the link, whatever you prefer. So my name is Romeo Kinsler. I work for IBM in the area of cloud and big data analytics, and today I want to show you something about Cloudfoundry, which is a platform as a service cloud standard, and I want to show you how to use it in conjunction with Python. And I've prepared some demos how to use that, and also some data analytics number crunching, which we then can do using SciPy and NumPy. I'll do a little introduction now about the platform cloud and the open standards in this ecosystem, and then I'll directly go into some demonstrations of how to use it together with Python. Okay, so this is kind of the funny picture how to differentiate the different ways of doing cloud today. So I think traditional on-premise everybody understands. That means actually you have everything in your data center with a low level of automation, and many employees are working for you, kind of doing the operations for your hardware and software. You have network engineers like the crack sitting in the first row here. And you have middleware engineers, database administrators, and everything what you need to run such a data center. The first approach of parallelizing this was infrastructure clouds, and one of the first players Amazon Web Service. And from then on, a lot of competitors are now offering clouds. So nearly every large software vendor now offers a cloud solution, and also a lot of startups are coming into this ecosystem. Then I will skip PaaS for now and go to SaaS. So then the SaaS way of delivering software is quite common. So you know that from Gmail or other mail providers and Salesforce and so on. And now in between, a new way of cloud delivery is emerging. That's platform as a service. And actually that means you provide only your source code. And let me just change this to this view. You provide only your source code or your application and data, and everything else is managed by the cloud provider. And there are proprietary standards in the market and open standards. So the proprietary standard is, for example, Amazon Web Service or Google App Engine. In the case of Amazon, it's called Elastic Beanstalk. And there are two main open standards at the moment. One is called Heroku, and the other one is called Cloudfoundry. And we have the feeling that Cloudfoundry will be the de facto standard in a couple of years for platform clouds. And we are not the only one thinking this. So I just want to get rid of this. Okay. So you go for Cloudfoundry and consortium, so you see that there are, besides Amazon and Google, a lot of companies are in that consortium. You see here a list. So it's IBM, HP, Fujitsu, and SAP. And one interesting thing is that not only cloud providers are in that consortium, also software vendors. And the reason behind that is that in the platform cloud, you are consuming services, and these services are brought to you by software vendors. It's basically right here. So based on that open Cloudfoundry standard, which is implemented by various cloud providers, and I will show you now the IBM Cloudfoundry Cloud. So it's you can go to join Bluemix on that link, and you can enter there. There's a free tier, and it remains free, so you can run production applications in Cloudfoundry in the free tier. And one key aspect of Platform Cloud solutions is auto-scaling. So you are in the free tier, and in case your application needs to scale because you have a lot of users, and hopefully then you make a lot of money out of that request, then it scales up on the middleware side and on the services side. So the idea is basically that you have a catalog here, and the catalog consists of two types of components. And one is runtimes. So you see here the blue ones. These are runtimes which are supported by IBM. So for these you get 24/7 support if needed. That's Liberty Profile. It's a JEE container, like Tomcat, for example. And this is Node.js, and that's maybe one of the first times in history that a big commercial software vendor like IBM supports an open source JavaScript server-side middleware. You see here Go, PHP, Python, in this case Ruby, and then you see here bring your own. And that's the cool thing about Cloudfoundry, because you can plug in runtimes for every programming language. And I can give you an idea. So if you search for BuildPack, BuildPack is the name for plugin in the Cloudfoundry cloud. And you search for Cloudfoundry. So there are some official open build packs. See here Go, Java, Node.js, PHP, Python, Ruby. But the cool thing is you find them on GitHub. And these are maintained by the community. You see here a lot of build packs for programming languages and technologies I never heard of. And another cool thing is, since they are open, you can fork them and you can modify them and then use it in conjunction with your application. And in case on the main trunk something is changing, you can rebase your fork and then you can basically update your modified build pack. That's basically the build pack thing, and then there are the services. And in the Cloudfoundry cloud, the services are not limited to what the cloud provider is offering. The services is an open system. And in this case, we have services which are provided by IBM. These are the blue ones. You see here some are beta, some are in production. And then there are third-party services. And the third-party services, they have another color. And they are basically brought to you by another partner of IBM. And everybody can become partner of IBM. It's kind of an app store for services, and like every week, one or two more services are in there. So I'll give you an example. If you go to data management, So you have Apache CouchDB as a service. You have OpenStack, Swift storage as a service, a DB2, MySQL, PostgreSQL, MongoDB, Redis. And some of them are brought to you by IBM. Some are third-party vendors. For example, MongoDB is directly brought to you by Mongo Labs in New York. And you can easily just click on them. And every service in Bluemix has to have a free tier, a production free tier. And that's basically defined by the service provider what they want to give you for free. But in this case, it's 500 megabytes of storage. And then you can book additional tiers in case you need more storage or higher performance or whatever. Okay. I will do now a little demo with PHP application because PHP just only needs one single line of code, and that's already an application. I want to show you how this can be deployed to Bluemix. And I did this before. Okay. So you see, it's an empty directory. So I'll do it from scratch. And so that's maybe the smallest application you can think of. It's funny that I use PHP to do that. So, and now there's a command line tool for Cloudfoundry, and this is open source. It's not coming from IBM. It's based on the Cloudfoundry distribution, and you have now to log in to the cloud, which I do now. So actually you can share accounts on the cloud with others and also give them access. So I could also access the account of others. There are different workspaces which I can define. And since you only pay for main memory consumption, you can define as many workspaces you want to. So I have a development, a test, and a production workspace, for example. So now I've logged in. And now I can basically install this PHP application to the cloud. And that's the push command. So everything nowadays is push. It's Git and Docker and Cloudfoundry. Every system needs or uses this push command. And now I define a name. So that's and now comes the important part. I define a build pack. So I tell Cloudfoundry which runtime plugin to use. So now I'm searching for the PHP build pack. And most likely first hit is a good hit. So this is a PHP build pack which I can use. I pass it as a parameter. And now what happens in the background is a link or a route is generated. That's an entry in a HTTP routing table, which actually says that the Python hack session ch.mybluemix.net is routed to my application. That's happening here. And now it's failed. Oh my God, I have installed so many applications that I haven't enough main memory. So everything is now based on main memory here, but that's a good point to show you the dashboard. The dashboard actually tells me what runs on my cloud. So what you see here is the IBM web interface. The web interface is implemented by IBM and accesses the Cloudfoundry API. So everything what you do in the web interface you can do using the command line. And there's also Eclipse and Visual Studio plugin for that. I can show you the Eclipse plugin later if you like. So I have to get rid of something here. So delete me is maybe a good thing to delete. Okay, so if I go back to the dashboard, I see I have 7.63 GB of memory, so this should work now. And what I can do in addition, I can define the upper bound of main memory. So I assign 64 megabytes to that Python application, which is more than sufficient. Yeah, sorry, PHP, yeah. So what now happens, Cloudfoundry itself accesses the build pack, so it just downloads the contents of the PHP build pack. And this PHP build pack contains some scripts in order to install Apache and the PHP module. And the target of this is empty container. I will explain you later what the container is, but basically it's something like a lightweight virtual machine. And into that, the HTTP server or daemon is installed and started, and also the PHP file is copied to there. And all that together is then called a droplet. The droplet is a zip file. The zip file is then stored into a fault-tolerant distributed file system on the cloud. And the good thing then is that you can start as many containers as you like. They just pull the zip file from the distributed storage, and then you can easily start multiple containers. So this should now be up and running. So I go back to my browser. So that works. And you should also see it here in the dashboard. If I go to apps and this one here, then you see here that this is the PHP application, and I consume 64 megabytes. And I can also say okay, let's please start 2 additional containers, and then I can handle 3 times the throughput because there is an elastic load balancer already in the Cloudfoundry standard. So what I do now is I give you an overview about the components of Cloudfoundry, and then Madeleine here will do a little demonstration how to actually do the same thing what I've done with PHP using Python. And then we will extend this example with some additional code and push it to Cloudfoundry. And once this works, I'll give an overview of Docker, and we will do the same thing in Docker. And then you have a good overview of 2 very interesting and compelling standards, which are now kind of disrupting the PaaS ecosystem. So what I do now is I'll give you a short and simplified architectural overview of Cloudfoundry. So a central component is the router. So this is a HTTP router. So it's a layer 4 router. 5. And here are containers. And the containers in Cloudfoundry are called Droplet Execution Agent. And these are these virtual, lightweight Linux machines where your applications are running in. And one very important component is the service broker. And then outside of Cloudfoundry, there are the services. So they are not part of the standard. And there's another thing, which is called the health manager and the controller. So everything enters via router. That means you can't access anything else than HTTP or HTTPS using Cloudfoundry, because everything has to run through this router. Also, accesses to the controller. So I have logged in and I have pushed an application to Cloudfoundry, and my command line tool was actually talking to this controller. And this controller creates the droplet and just pushes it to these containers. And once this is running, the health manager is monitoring this droplet. And the only thing what you have to do is you have to open a port and you have to answer HTTP requests. And if you don't answer status code 200, then the health manager will consider this container as dead and will restart it 3 times. And if this doesn't succeed, it tells, basically the health manager tells the controller that this container is dead, and the controller will restart it 3 times, and if it doesn't succeed, then it will issue a message and you will get notification that your container died. In addition to that, you can plug in a monitor to the router, which monitors throughput, response time, and you can monitor main memory and CPU usage of the containers. And in case of Java-based application, you can also monitor the Java heap size, and you can define rules and thresholds. And for example, if the response time is increasing a certain threshold, then you can define that multiple containers are then instantiated in addition. And since here's a load balancer, the router will do round robin to these containers and increase throughput and minimize response time. And one thing is the service broker, since you have now only a standalone application, but you want to use, for example, databases, message queues, or anything else. And as a third-party vendor, you can register your service on the service broker, and then you can bind the service to your container. And this is only for the management, and later on you do a plain TCP connection to the service. So that means to offer a service to in the Cloudfoundry cloud, the only thing you have to do is you have to have a TCP port opened anywhere in the world on a public IP, and you have to implement a couple of REST services in order to communicate with the service broker. And then every user of the cloud can then book services from you, and you get then a request to provide such a service, and you return basically the endpoint information. That means IP address, port, username, password, and so on. Or in case of a database, you need a database name. And then the application then directly connects to your service. So that's Cloudfoundry in 5 minutes. And so I give the stage to Madeleine, and I think you told me you have sent me a link. You know this by heart, or shall I open my email? Okay, can you try to Google it, or? Okay. Okay, so we will now do a demo on Flask. Who of you knows Flask? Okay. I think all of you are much better in Python than us. And there is a sample application in GitHub for a Flask application which is already ready for Cloudfoundry. So you can publish this Hello World Flask application to any Cloudfoundry cloud. And since Plumix is a Cloudfoundry cloud, you can publish it to Plumix. Okay, yeah, if not, then I will just open my email account, not a problem. She's just creating a folder and now clones the example into that folder. Who of you is using GitHub? Okay. Okay, now we have the folder there and you see a couple of files. So this is the actual Flask application. Yeah. And here you see one important thing. You see here you have to read a Linux environment variable. And that's the way how Cloudfoundry tells you on which port you have to listen. And the router then will forward all requests to the IP address of the container and to the port. So multiple containers are co-located on one single physical machine, and every container is assigned a port where he has to open a TCP listener or HTTP listener, basically, and then the router forwards our request to that port. So if that variable is not set, the fallback to port 8080 won't work because the router, not a health manager, checks on the port which he has assigned to the container if it's up and running, and if not, it considers the container as dead. So then we can have a look at the other files. We can maybe the manifest YML. So that's a really simple example, but you can define the name of your application, and this will also, if not overridden, be the URL. .myplumix.net. Of course, you can use any other domain name and include it in Cloudfoundry, the memory limit. And you can also specify services. So you can tell the Cloudfoundry cloud, please, in addition to my Python runtime, I want to have a MySQL service with that size or in that plan. You can specify it here. And when at the point you install this application, the MySQL service also is started and then bound to your application. And the credentials to the MySQL service you can read also in such a environment variable, which basically contains an array of JSON objects, and then every service is a JSON object in that array, and you can then connect to the service. Anything else? Procfile maybe? Okay, that's basically how you start it. So that's Python, the command to start the application. And requirements, it's just a list of packets which are then installed using pip. I think pip you all know. I know it's in 1 week. Okay, so now you can install it in Plumix. It doesn't matter. You can use mine. Or you can use yours. Whatever you like. Maybe you have some more memory free, but you will see. So now she does the same as I have done for PHP. She gets the official build pack, and I say official because initially Cloudfoundry was invented by a company called Pivotal, and so they maintain a kind of semi-official list of build specs. Oh, that's the problem with my keyboard. I have problems with the B. So. Yeah. But next week I get a new one, so. Maybe it works if I have enough memory. See here, it's creating the root again, binding the root to the container. By the way, in case you have any questions, you can just interrupt and ask. Yeah? Yeah, you can bring them. So I can show you later if you like. You can manage your URLs, and you can attach certificates to these URLs. The instances are in the same geographic location. And they might run on the same machine, or they might run on another machine. This is transparent. At the moment, IBM has two, London and Dallas, Texas, and we will roll it out worldwide in all our data centers. So we have, I don't know the number, 40 or 50 data centers worldwide. The next one is Frankfurt, and we will have Bluemix by end of year in all these data centers. No, you define which data center you want to use. Yes, so if you want to have load balancing on a global scale, you have to install a load balancer in front, and the load balancer in front then decides which data center to use. And the load balancer, which I have drawn here with the router, it's a data center-wide load balancer, not a worldwide. Okay, so this application now is up and running. B is not so good, no? What? Okay. Yeah, I think so. Okay, and here you see Cloudfoundry told us please run on port 63214, and the router actually then translates port 80 and forwards this request to the container on this port. Okay, thanks a lot. Yeah. You can run a cron job, so because depending on the programming language, in Python I think it's possible, you can start threads, and these threads are running. So there's not an official cron scheduler in Cloudfoundry defined. If you want to have cron jobs, then you have to implement it yourself or use a framework. So there's at least one framework in every programming language for cron jobs, and that works. So I've implemented this in JavaScript or Node.js, and I assume in. Yes, you can do any network traffic you like from a container. There is no firewall; it's not limited. So you can also do TCP connection, and that's also the way how these services are working, because from the container you do outbound TCP connections to some servers in the world. Otherwise, you never would be able to connect to MongoDB running in New York from Dallas, for example. Yeah? OpenShift is something which Red Hat implemented, and I think it's not an open standard, or is it? It's open source, yeah. So that's an addition to Cloudfoundry and Heroku. But I have read some tweets about that, that Red Hat most likely has to adopt Cloudfoundry because the whole ecosystem now is doing Cloudfoundry. But the concept is more or less the same, I assume. Yeah. But I'm not an OpenShift expert there. Any other questions? Yeah? Oh, okay. I will do this later on the Docker part, but I can tell you maybe the foundation of that. So Google was transforming the whole architecture of their data centers a couple of years ago. So they don't run any virtual machines anymore. And they found out that it is more efficient to co-locate load on physical hardware without having to install an additional operating system. So in order to isolate the processes of an application, they have done a modification or two modifications to the Linux kernel. One is called C groups and one is called namespaces. And namespaces basically is a way to give access to subtrees of the process tree and to subtrees of the file system to a container. So that means if you are inside a container, you have only access to a subtree of the process tree, and you only see your processes. And the same is for the file system. You are not like a chroot environment. You are not allowed to go up the tree, only down. That's the namespaces extension, and there's the C groups, the control groups extension, and this basically allows to assign certain threshold for a process group for CPU usage, main memory usage, I/O bandwidth, and I think this, and that is used by the containers to separate processes from each other. And inside the container, you have the feeling that you have only a subset of the resources of the physical machine. And in Cloudfoundry, the technology for these containers is called Warden. And there is another ecosystem now growing. This is called Docker. Who of you have heard about Docker? Who of you have used it? Okay. And now Google has a Docker cloud, Amazon has a Docker cloud, IBM has a Docker cloud, Microsoft announced to have a Docker cloud. Google now announced that they will move away from Docker and implement something called Rocket, but it's basically the same. There's a startup in Silicon Valley which is called Docker and which maintains, in addition to the technology, also a repository for these images. But I come to that in a couple of minutes. What I want to do now is to implement a little application on Flask, which is basically a little application for data science. So I will use NumPy and SciPy to calculate the correlation between two lists of values. And these two lists of values I have derived from a genomics or life science data set. So just to make it a bit more interesting, who views in genomics? Nobody. Okay. So you can draw your genome like a sequence of characters of length something like 7 GB. So these are these A, C, G, T characters. And there are subsequences on that genome, and these subsequences are called genes. And these genes basically they code for something called proteins. And we have around 25 to 30,000 genes. And life scientists are doing experiments, and cells are reacting to treatments, and then some genes are up and down regulated. For example, if the sugar level increases, some cells in your body are creating more insulin, and insulin is basically a protein, and the gene which codes for this insulin is then upregulated because it produces more protein. And in this data set, I have just 24 experiments, 12 female and 12 male, and 8,700 genes. And for every experiment, I have a number, which means if the gene is up or down regulated. And if you do life sciences and genomic experiments, then you have to calculate the correlation between two experiments, and that you do basically by calculating the correlation between the list of genes. So I just show you the data set. So you see I have 12 female and 12 male experiments in that data set, and who of you knows R in this room? Okay. So I basically have to explain nearly nothing. Huh? So I just show you the dimensions of the data set. So you see there are 24 experiments on 8,793 genes. And what I've done in R is I have created a list of 2 experiments. And this list I'm writing to a text file, and that text file I can just use to push it to the application in the post request. Okay? I've prepared that somewhere. Yeah. So that's basically that's the data set. And you see here, it's X, and then there is a list of values. It's 7,700 something values. And then there is a Y, and there's also 8,700 something values. And these 2 lists I pass to the Python application, and then parse it and create an array using NumPy. And then I calculate the correlation coefficient using SciPy, and then I return it. That's basically the application. I show you the application now. Let's use this one. So that's basically all. So I read X and Y from the request, from the post request, and I create an array, that's NumPy. And then I have X and Y as an array, and then I just call this function from SciPy, which is the Pearson coefficient, and I get back 2 values. That basically was new for me, because I'm a Java programmer and there's only one return value, quite handy. And then I just return this concatenated string back. Okay, that's all. So I will do the same like Madeleine was doing before. And what I do is I will reuse her command, basically overwriting what she has done with my application. And I haven't tested that, but it should work. I have to check whether, so I've already modified that Python will now start the welcome_post script, and then I hit enter here. I have to show you the requirements file now, because the requirements file now, in addition to Flask, contains SciPy and NumPy. No, it doesn't work. I've tried that. So the build pack is somehow not able to install NumPy and SciPy using the requirements file, it gives me an error. So what I have found out is that there is actually a SciPy and NumPy build pack already built by somebody, and that's an example how you can just use, yeah? Yes, and I think that's the reason why SciPy isn't working like this, because SciPy most likely uses the extensions, and therefore you have the answer already here. You have a custom build pack. In Docker, it's a bit different. We'll see that later. There you have basically a Linux environment, and you can do whatever you like. But I have to confess that I also had problems with the pip tool. So pip is not my friend, and I just used apt the app tool from Ubuntu and installed the SciPy and NumPy there. So that's maybe an open issue to do this with pip. So that was this one. You see then this guy here, the Novices, he has provided this SciPy build pack, and then this works. Any questions while I'm installing? Yeah? You could somehow hack it into the build pack, because Cloudfoundry will call a couple of scripts on your build pack, like init and setup and start and stop and so on. Yeah, you can do it. But the recommended way to do it is using a build system. And in case of IBM, we have built a build system, which is on this second link there. It's Join DevOps. And there we basically have Jenkins as a service. And there you can define different stages, like building in case of Java or Scala, where you have to compile. And then you can define test stages, so you can run unit tests. You have deploy stages, and you can deploy your application to Cloudfoundry or Bluemix and run integration tests in the development space. And if that succeeds, you can then deploy your application to test, integration, or even production. So this way you can implement the whole continuous integration and continuous the delivery pipeline. But that's, I think I don't show it today, but yeah, it's quite easy. Any other questions? No? Okay. The container technology is called Warden. Most likely they are going to replace that. I've heard something in this. Yeah. Well, the thing that I'm wondering is probably you usually have a problem that you have switch. Yeah. Okay. And then you have to rebuild your whole application. Yeah. Okay. So in the case of Warden, there are no such things like images. So Warden container is behaving like an empty operating system, and the Cloudfoundry build pack actually will install the whole environment for you. So you mean if the security problem is on the operating system or on the contents of the build pack? Well, there can be security problems, yeah. So I am sure that the same required. Okay. Now, in this case, since you have no commercial support, you have to either convince the guy to put it in, or you have to fork and do it your own. In case you get pip up and running, then it's more easy, because if you don't specify the version in the requirements but text file, I assume it will get the latest version, and then you are out of the problem. Yeah. So this has worked. So if I open that in the browser, it most likely doesn't work, because I expect some data to be sent. Yeah, okay. And now I do that. So I use this curl tool. I say method post, and I attach this text file which I've created using R. And this is basically already for my other demo. So this is basically for the Docker demo. So I will just use this Cloudfoundry link here. And so this should work. Oh, thanks a lot. Okay, so you see here the correlation coefficient is 0.987. Let's verify that. But I have used F2. Oh, no, I used M1. Oh, no, I used N2, so. Okay, good. So then SciPy and R are thinking the same. This is a good thing. So now we could, for example, if we now have a more complex operation and we need more resources, we can do two things on Cloudfoundry. And that's basically the point of, in my opinion, of platform clouds. It's not about ease of use, that's a cool thing. It's about binding services to your application, but it's the microservices approach, which was invented by Netflix, that you monitor your service and you define the upper threshold for response time, and in case the response time increases, you provide additional resources. So if I go back to the dashboard now and I go to my applications and I go to this SciPy NumPy application, I can either increase here the number of instances, but what I can do in addition to that, where is that? I can attach auto-scaling. I won't go into the details. You can believe me, it works quite nice, because such a container starts really fast, and you define thresholds, and you don't notice the difference when an additional container is provisioned or not. So that's basically what you get for free in such clouds. Okay, so this was basically Cloudfoundry. Now we have half an hour left for Docker, so we will do the same thing now in Docker, and I will show you how to create the image. I have created the image based on a Ubuntu base image. Who of you has no idea about Docker? Okay, so I will do a short introduction. So what I do now is I go to my Docker example. And there's a thing called Dockerfile. Which is not the latest one. So that's the file. So Docker itself provides you a couple of base images. One is Ubuntu, and if you specify latest, you always get the latest stable one. In this case, it's 14.04. And then basically this image is started and these commands are run. So I do a git update and I install NumPy and SciPy. And I think I have also to install Flask. And then I have Ubuntu plus the Python components I need. And then what I do, I copy my Python script into the image, and I tell Docker that it shall open one port for me. So this port is where the application is running on, and then the command Python and the script is started. And this all is then basically copied into so-called image. And this image is lightweight because the image only contains the diff between the Ubuntu base image and what I've then added here as file. So if you ship the image to somewhere else and the other one already has a Ubuntu base image on the machine, you will only get the diff out of the repository. So that's the basic concept. What I've done is I have created Ubuntu Python image, which basically is everything up to here. So it's Ubuntu plus the Python components, which I have then called Ubuntu Python. And in that image, I include the application, I expose this port, and I run the script. And I will just rerun this, let you see how this works. So I will do a build. Basically, that's the command to create the image out of a Docker file. I have, of course, to start Docker. So that was it. And now I will start it, and then you will see how amazingly fast this works. So now I use the image which I have created. So let's have a look at what I have on images on this machine. So most of these images are coming from the Docker repository, but some of them I have created on my own, and I will now search for the one just created. So this one. And I will use this image to start a container now. Yeah, this is the command. So, and that was it. It was less than half a second. And this output basically is generated by the Flask application. So that actually means that I have a container now running on my system. I will show you this here. So you see here that this container is running. 25 seconds ago I've created it, so that's the proof basically that it was me now. And you see here port mapping. So I map internal port to external interface on port 5000, and now I should be able to access this container running on my machine using a browser. So I have to go to port 5000. And maybe it's another port. What? That one is the interface. So I think the internal Docker interface is another one, but we do a little trick here. Okay. That's a completely new behavior to me. I don't know what I've done wrong, but you're absolutely right. I will replay my video and see what I've done wrong later. So then I now can stop no, I can't stop this. I have to use my CURL script, and I will replace this. So this accesses now the Flask application in Docker, and I will see if it still works. It still works. So now we have a local Docker image, and now we want to push it to the cloud. And in order to do this, you have to install an extension. So the Docker command only works on the local system, and there is an official way to extend Docker. And IBM has created a command which is called ICE, IBM Cloud Extensions, which basically wraps the Docker command and does some additional things. And I will just now use a cheat sheet to do this, because I've written a blog article on that, and since I don't know all the commands by heart, only 2 or 3 commands, but you have to know them. Okay, so you have to log in to the IBM Container Cloud. This basically is a composite tool, so it has the Docker tool in it and the Cloudfoundry tool in it. Wrong password. Why? Okay, once again. Currently, the Docker Container Cloud is in beta. It will be in production by summer. And there also will remain a free tier. So there's some 2 or 8 GB of main memory you can consume using Docker images on the cloud. And you can ship these Docker images anywhere you like. No, you can run it anywhere you like. So there's no vendor login. Okay, this succeeded. What I now have to do is I have to tag my local image. So I go back to my list of images. Okay. And grab Ubuntu Python. So, and here, this is the image ID, and I tag this image ID with a name, on the IBM repository. So this second string is the name which will be on the IBM repository. So IBM has an own repository. It's a private repository for you. And since it is tagged, I now can push it. So I push my local image, which I have now created myself, to the IBM Docker repository. And you see here, this image is a composition of multiple layers, and you see here that they've been already pushed. So most likely only the last layer which I've created is pushed. You see here, I have modified something on that, and the last thing is pushed. And now I have this repository, this image in the IBM repository. I can start it using command line tools as well, but I'll show it to you now in the web interface. So that web interface is basically handles Cloudfoundry Docker and also OpenStack. So you can also have virtual machines based on OpenStack, and you can manage them in the web interface, or you can manage them using OpenStack command line tools or APIs. Everybody knows OpenStack? Yeah, so OpenStack basically is like Cloudfoundry standard, but for infrastructure clouds. So there you can start and stop virtual machines. You have block storage and file storage, and all this is based on the standard. And if you have an infrastructure cloud based on OpenStack, you basically can use it with your tools, and there's no vendor-specific login, at least in theory. So I go back to my dashboard, and I go to containers, and I create a container. And since now my image is in the repository, I can just start it from there. So you see here, that's the image I've uploaded before. And so there are two things I can do. I can either start it and assign an IP address to it, or I can define a scale group, and that means I have multiple containers in the scale group, and I can do something like elasticity in that scale group. So I don't define IP, I only define a route on the Cloudfoundry router, and this router then is round-robin to my Docker containers. So I Meetup, and I first say deploy it as a single container, and I have to assign an IP address, and I say next, and I hope this works now. And basically, the command for doing this on the command line is this ice-run command, which is basically the same as Docker run. And then here is ice IP request, which gives you a list of IPs which you can use, and then you bind the IP to your container, and then it's up and running. And that's the same like doing it using the web interface. So this has worked, so I can use this public IP address and check whether on port 5000 I have something running. Yes. Oh yeah, I messed it up. That's a good point. I should have specified the ports. So thanks a lot for helping me. So let's delete this container. Let's see whether I can do it in parallel. So I will need 2. I define also the main memory consumption here, single container. I have only one IP left so far, and I say public port is 5000, and I deploy. So let's see if it works. So there's a kind of security thing in Docker, and you actually have to specify which ports you open. It's kind of a built-in firewall, and I forgot to specify port 5000. So there's no port opened on the container from outside, and I will now open port 5000. So let's try it again. No, I don't know what went wrong. So I just close all that stuff now to get a more overview. So container is running, public IP is correct. With me? That's a good question. I will check this, because I have rebuilt the application Python Docker and welcome. Now it's port 5000, so that's correct. I actually don't know what happened, but I was trying this 1 hour ago. It was working. I don't know what I've done wrong now, but that's the way to do it. Okay. Then I just want to show you the scale group, and then I'm finished. Yeah, of course, I could go into virtual machines, but that's straightforward. So I will create a container. And instead of assigning IP, so as a Python up scale, I say deploy a scalable group. 2 instances I will create. And now I define, instead of IP, I define URL. So I tell this scale group that this URL should be mapped on port 5000, and I can do auto recovery. And I'm deploying now the container group. And at the same time, I can use the ICE tool to do, for example, the PS. That's the same like using Docker PS on a local machine. Now I see here all the containers which are running. So this is still building. This is my scale group. These are the 2 containers of my scale group. And this is the one still running. Just give it another try, because I really don't understand this, why not working. Now it works. So that request means it works, because I'm not sending a post data. So I will do that now. I go to my CURL tool, and I will now replace this IP with the IP of the container. You see, and that's now coming from the single container running in the Bloomix Docker Cloud. And now, last but not least, if this runs, I'm happy. This is now the scale group, and the scale group I've assigned a root. And I don't remember the root. It's this one. So let's check whether this works. So this is listening to port 80. So this route now is running through the Cloudfoundry router, and it's load balancing between the two Docker containers. And of course, you can define also a scale policy and tell the Docker Cloud to instantiate more Docker containers in case the response time increases. And as I've told you, starting a Docker container takes around 100 milliseconds, so this really reacts elastic. And I will just see whether this works. So what I've done wrong now. Item scale. Yeah, but I've not assigned an IP to the container. I've just created a route in the Cloudfoundry router, and this router should now forward this request on port 80 to one of my two Docker containers. And I don't know why it's not working, but yeah, I think you get the point. And auto recovery basically means if a container dies for some reason, a new one is started. Yeah, that's basically the stuff I wanted to tell you. So are there any questions? Yeah? Yeah, the base OS is provided by Docker itself. Excuse me? Okay. So in case of Bluemix, we do that. IBM will ensure that the OS where the Docker containers are running on is on a secure level, and the same holds for the Cloudfoundry containers as well. Yeah, you can move them, yeah. Yeah, we have to take care of it. We are still in beta until summer, so we have to have a solution for that until summer, but that's the basic idea, that it runs without interruption. Because the idea basically, if it's Docker or Cloudfoundry or whatever microservices-based architecture, is that your containers are stateless. At least they don't consist of persistent state. You have to have your persistent state in a database or in a file service or whatever. And session state you have to replicate to a service. So we have, for example, a distributed key value store in Bluemix, and you can replicate your session state to this, and then you can basically start and stop containers as you like. And the Cloudfoundry router is session aware, so it can read some sorts of cookies and URL session keys. For example, this works for Java. I don't know if it works for Python. I have to check on that. But then the router is also session aware, and it will always route a request related to a specific session to a specific container. And if you do session replication and the target container is not aware of the session ID, it then has to get the session data from the distributed key value store. And the container which actually are having sessions running, they always have to replicate the session state to external service. And if you do that, then the containers are completely elastic. You can always start and stop them and move them around. Okay? Other questions? The logs, they land up in the container, but the file system is transient. So in Cloudfoundry, the file system is always transient. That means you have the log files, you can pull the log files from the cloud to your system, but once the container is restarted, the log files are gone. So you can modify your application that the log files go into a persistent storage service. By the way, there are multiple services in Bluemix or other clouds that are capable of handling the load of such log files. And what Docker also provides are persistent file systems. So you can also assign a persistent file system to a Docker container and use that. Because in Docker you can also run databases, if you like, which you are not able to do in Cloudfoundry containers. not so easy. You have to somehow do a graceful shutdown of the application, and or you have a database which is able to be moved. There are some sort of NoSQL databases which can do that now. How is it called? FLOCK? Uh-huh. Uh-huh. Okay. Okay. That's cool stuff is emerging. Yeah? There's also a lot of orchestration tools emerging, commercial ones, so IBM has Smart Cloud Orchestrator, or open source ones, Docker Machine, for example, and Puppet and Swarm and all that stuff. So it's quite hard to catch up. Other questions? Yeah? Yes. Yeah, they are building Docker for Microsoft Windows Server something, and inside these Docker containers then you can run .NET applications. We don't know exactly how it will work, but they committed to do it. And also IBM committed to have Microsoft-based containers in Bluemix. No, it's announced. Okay. Yeah. With me? I think all cloud providers have to maintain a certain balance, and I don't think there is much difference in future on price, because the service is quite the same, and if you have a higher price, then you won't get clients. The thing on Cloudfoundry and Open Cloud is that there is some substantial more services than on closed systems. So I think Amazon, Google has like 5 programming languages you can use, and like 5 or 10 services. And I think in Open Cloud, the number of supported programming languages is like infinite, because it's a plugin system. And also this marketplace service ecosystem which the Open Cloud technologies provide will sustain a much higher number of services. Yeah. Exactly, yeah. Exactly, yes. Prices will be close. Yeah. So the differentiator most likely will be the number of services you have, and maybe some additional features for enterprises like security, ISO certification, and so on. So our soft layer cloud is enterprise ready. You can run banking applications. All the ISO certification levels are there. Maybe that's an additional differentiator. Yeah? Yes, that's the basic idea. Yeah. It's the case, yeah. So IBM and Google have their Docker Container Cloud in beta. IBM will be in production in June. So this is in 2-3 weeks. And Amazon announced last month that they are in production. So you have up and running Docker clouds, and every major provider will have it by end of year. And you can ship them. You can run them on your system. You can run them on any cloud. That's the idea. You can share them in a repository. They are really lightweight. You can start 100 containers on your laptop in 1 second. Great technology. Yeah? Is it? Okay. I can't answer that. I don't know. I will ask the lab guys about that. So maybe we can talk about that later, and I will note it down. And I didn't know that. Yeah. Okay. Yeah. CoreOS is supported on SoftLayer as an image. In Bluemix, CoreOS is currently not supported, only Ubuntu, CentOS, Red Hat, SUSE, I think. And the idea is you don't need CoreOS as a virtual machine since you have the Docker Cloud. Yeah. Okay. 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 Mhm. Okay. Uh-huh. Okay. 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 So if you want to use CoreOS and IBM, you have to go to SoftLayer. And on SoftLayer, you get also bare metal machines, which you can manage like a virtual machine. I think that's also a differentiator between other providers. And you can basically build your own Docker hosting environment there at the moment. Yeah. No more questions? Comments? Feedback? Okay, so outside there are soft drinks, beer, and some finger food, and I'll be there if you have any other questions. Thanks a lot for coming. Thank you.